Question 761. The length of the curve y is equal to arc sine x from x is equal to 0 to x equal to 1 is given by which of the following? Okay, remember the arc length of the function f from x is equal to a to x is equal to b is given by a to b square roots 1 plus f prime of x square dx. That's our formula, right? So here we have function y is equal to arc sine x. Y prime is equal to 1 over square root 1 minus x squared. What's y prime square? Y prime square. Then that's going to be 1 over 1 minus x squared, right? So we have to substitute this expression right over here, right? So our arc length, let's say it's s, is equal to from 0 to 1 square root 1 plus 1 over 1 minus x squared dx, right? So the answer has to be B. Question 762. Write but do not evaluate an expression involving one or more integrals that gives the length of the curve y is equal to e to the 3x minus natural log x cubed from x is equal to 1 to x is equal to 2. Okay, if we rewrite this function, y is equal to e to the power of 3x minus, using property of logarithm, we can write 3 times natural log x, right? 3 times ln x. So y prime is equal to e to the 3x times chain rule minus 3 times natural log x. So y prime square is equal to 3 e to the 3x minus 3 natural log x, all of this expression square, right? Our arc length s from 1 to 2, right? Square roots 1 plus y prime square. So 3 e to the 3x minus 3 natural log x square dx, right? That's our answer. Question 766. The region is separated into 2 different regions A and B by the line x is equal to b, as shown in figure above. If the curve is given by y is equal to e to the power of negative x, how much greater is the perimeter of the region A than the perimeter of the region B in terms of b? And it says to write an integral expression only. Alright, let's find the perimeter of region A first. Okay, the length from here to here is just 1, right? From here to here, that's B. And from here to here, let's say this is A. Alright, this is curve, right? So we're going to have to use the formula of the arc length, right? Let the length from here to here be m, okay? So that's m. So m is integral from 0 to b, right? Here's b. 0 to b square root 1 plus the derivative of a function y square dx, right? Here we have y is equal to e to the negative x. So y is equal to e to the power of negative x. Y prime is equal to minus e to the negative x, right? Then what is y prime square? That's going to be negative e to the negative x square. So that's going to be e to the negative x times 2, negative 2x, right? So this is equal to square root 1 plus e to the negative 2x dx. right? Okay, let's find the perimeter of reason B. Okay, here is just the 1 minus B, right? Here is, we say it's A. This one right here, since the function is y is equal to e to the negative x, when x is equal to 1, y is equal to e to the negative 1, right? E to the negative 1. So the length from here to here, that's e to the negative 1. Or we can write that's 1 over e, right? And we have to find the length from here to here, this curve, right? That has to be integral. Let's say this is n. N is integral from 1, I'm sorry, that's b, right? From b to 1, same integral, right? 1 plus e to the negative 2x dx. So far so good? So perimeter of A, let's say this is perimeter of A, okay? Minus perimeter of B is equal to, what's the perimeter of A? That's 1 plus B plus A plus M, right? So 1 plus B plus A plus M is integral from 0 to B roots 1 plus e to the negative 2x dx minus, we have perimeter of B right here. That's going to be A plus 1 minus B plus 1 over E plus integral from B to 1 square root of 1 plus e to the negative 2x dx, right? So if we simplify this, that's going to be equal to, here we have 1 minus 1, right? That cancels out. B minus negative B, that's 2B, right? So we have 2B. Here we have A minus A. So that cancels out, right? And we have minus 1 over E, right? So 2B minus 1 over E plus integral from 0 to B square root 1 plus e to the negative 2x dx minus integral b to 1 square root of 1 plus e to the negative 2x dx, right? So this is our expression for the difference of this perimeter and this perimeter. So the perimeter of reason A is this much greater than the perimeter of the reason B. All right? Question 767. The length of a curve from x is 1 to x is 2 is given by definite integral right over here. If the curve passes through the point 1, 3, write the function for this curve. Okay, it is given that this definite integral is the length of curve, right? If we simplify this definite integral, that's 1 to 2 square root 2x minus 1 square over 2x minus 1 square, that's 1, right? Plus 1 over 2x minus 1 square. So 1 over 2x minus 1 square dx, right? Since the formula for the length of curve is integral from a to b square root 1 plus f prime of x square dx, we know that this expression is equal to f prime of x square, right? Since f prime of x square is equal to 1 over 2x minus 1 square. That's actually 1 over 2x minus 1, all of this expression square, right? So f prime of x is equal to 1 over 2x minus 1. Let's find f. F of x is equal to we actually have to find the antiderivative of this, right? So that's going to be equal to net log 2x minus 1 with 1/2 with a c, right? That's our antiderivative of 1 over 2x minus 1. Now this function passes through the point 1, 3. So when x is equal to 1, y is equal to 3, right? So 3 is equal to 1/2 net log 1 plus c. We know that net log 1 is equal to 0, right? So c is equal to 3 minus 1 over 2, right? That gives us a c is equal to 5 over 2. So our function f of x is equal to 1/2 net log 2x minus 1 plus c plus 5 over 2. That's our function, right? Question 770. The table above gives values of the differentiable functions f and its derivative f prime at selected values of x. What is an approximation of the length of the graph of f on the interval from 0 to 6 if a left-hand Riemann sum with the two subintervals of equal length is used? We have already learned about left-hand Riemann sum. Let's say we are approximating this definite integral from 0 to 6, f of x dx using left-hand Riemann sum. Then that's going to be equal to each subinterval 3 times the value on the left, right? The value of a function on the left, right? So that's going to be -1 plus this interval 3 times the function value on the left, which is equal to, right? That's left-hand Riemann sum, right? In this question, we are approximating the length of the graph of f on this interval, right? Using left-hand Riemann sum, right? So we are actually approximating definite integral from 0 to 6 square roots 1 plus f prime of x squared dx, right? That is equal to, using left-hand Riemann sum, this interval times this value on the left, right? So here we have square roots 1 plus f prime of x squared, right? This is our function value. So when x is equal to 0, right? When x is equal to 0, this value is 1 plus f prime 0. That's 2, right? So 2 squared, which is equal to square root of 5, right? So 3 times the square root of 5 plus this interval, which is also equal to 3 times this value on the left, which means when x is 3, value of this when x is equal to 3, right? So when x is equal to 3, this value is square root 1 plus f prime squared. When x is 3, f prime is 1, right? So 1 squared, which is equal to square root of 2. That's our function value, right? So 3 times the square root of 2. Does that make sense? So that is equal to, if we factor 3 times the square root of 5 plus the square root of 2. This is our answer, all right?